if I get anything wrong, I'm sure somebody will tell me. But I'm just going to go with what I know about Boulby Mine, and stuff I don't know, you can fill me in if anybody knows more. Right. So Boulby Mine, as far as I understand it, it's the deepest mine in Europe, deepest working mine in Europe, and it's the deepest mine, the deepest potash mine in the world. It's the shaft is 1.2 kilometers deep, but the mine extends down to about 1.4 kilometers. So the potash discovered this, the potash mineral deposit was discovered in the 1950s sometime when they were drilling for oil. They were trying to find oil, but they found potash, and then they sat on it for a while, and then ICI decided to sink a mine to exploit it because potash was in short supply. So at the time the mine opened in the early 1970s, it was run by ICI, who already had experience in sort of halite mining and that type of thing, wasn't it? So yeah. Oh, it extends out into the North Sea about 3 or 4 kilometers. You know, the majority of where they mine goes out to sea. So the problem now is they've just, in the last year or so, they've stopped mining potash. As the mineral they were mining was potassium chloride, or muriated potash they call it, for a fertilizer, which is, I think it's between 45 and 60% potash. But they've changed over now to mining a different mineral, which is polyhalite, which is a better fertilizer in some ways, because muriated potash contains chlorine or chloride ions, and it's not really good for the soil, but it contains a very high concentrate of potash, which is good for the soil. So what they're doing now, that the company now, it's ICL, which is Israeli chemical company it's owned by, and they got other mines around the world. So they're mixing this polyhalite, which they're mining now, which is 14% potash, and they're mixing it with muriated potash, which they're getting from Spain at the moment, from a mine in Spain, and they're sort of blending it to make a new type of fertilizer that's not really been sold before. But that's the only that's like the only thing that's keeping the mine open, because they've exhausted the mineral deposits of the muriated potash. Mainly, it's not that they've exhausted it, but it's become the remaining mineral is too deep to mine. It's not practical and not cost effective to mine it, because has anybody here who've been down Boulby Mine amongst us now?
No.
Well,
no.
When you go down the mine, you get to the bottom of the shaft, and it's quite cool because there's draft in the shaft, and and there's a massive fan that's pumping air down there. But when you get away any distance away from the bottom of the shaft, the temperature it's unbelievable. The bottom of the shaft is about 30 degrees, and where the working deposits are, well, when I was down there, the working end of the mine, where they were mining the actual potash, was about 45 degrees, and that's 45 degrees C. That's the sort of highest temperature you can work in. Really, it's not practical to work at. As it is now, the miners have to sort of do about 20 minutes on and 20 minutes off, and they have hanging off their belts bottles of iced water. They have ice cubes and water hanging off their belts, and they keep topping them up every. They're drinking it all the time to keep them cool. It's unbelievably hot down there. But interesting things about mine, well, stuff that interests me anyway. I mean, I don't know about everybody else. The roadways are driven through salt. Obviously, it's a salt mine, like, isn't it? But it's not practical to mine salt at that depth when you can mine it, you know, so much easier nearer the surface, like at Winsford or somewhere. But they do mine the salt because it's a byproduct of making the roadways. The salt it's all rock, really, isn't it? You know, so the sodium chloride, which they use for rock salt. I mean, they mine it for rock salt, but it's much stronger. It's much physically much stronger than the potash. So the tunnels are liable to collapse in the potash. So they don't use them as main roadways because it's a bit too dangerous. So they mine all the roadways, the whole labyrinth of the mine is mined through the salt, and the potash is above the salt. So they drive the tunnels to where they want to go, where they've established that there's a deposit worth mining, and then they drive upwards into the potash. They mine that bit of potash, and then they get out of there and they let the tunnel collapse. You know, once they don't use it anymore, they just let it go. It's like a coal mine where it's much safer basically to bore all your tunnels that you're working tunnels through the salt. So that's what we do, and all of that salt, that road salt that they bring up and sell, is a byproduct, because it's the rock salt. At the time I was there, the rock salt was worth £15 a ton, but the muriated potash was worth £350 a ton. So clearly they don't want the salt. You know, they're only taking it out to get it out of the way, aren't they?
Yeah.
And they just get the £15 a ton for it because it's, you know, something to, you know, it's not really profitable, basically.
Do you know how much it costs to mine per ton, though?
I don't know. They never really told us that, but they just told. At the time I was there, the muriated potash was very, you know, it was very profitable, and they were doing really well. But since then, you know, in the last couple of years, they've basically run out of mineable resource. So they're changing over now to polyhalite. All of these minerals are, sorry. Oh, thought somebody said something. All of these minerals, they call them evaporites, don't they, or evaporates, because they're just evaporated. And another name for them really is halites, isn't it, because of their chemical constitution. But the way they're deposited, the salt is at the bottom. You know, the sodium chloride is at the bottom. Presumably, it must be heavier. I don't know, or it precipitates out. But all of them are basically a sea that's dried out, aren't they? Evaporated away. And the minerals that are left are, you know, salts and, you know, and muriated potash and all this. So the salt is at the bottom. The muriated potash is near the top, and then it goes into a clay after that. It starts, you know, above the muriated potash is clay. And below the muriated potash,
the reason that the salt is not that soluble in water, i.e. sodium chloride is not that soluble in water, potassium chloride is very soluble in water. So if you've got a mixture of potassium chloride and sodium chloride, and the water evaporates away, the salt will always preferentially drop out and form a base layer.
Yeah.
Water evaporates.
So that's why it's at the bottom.
Yeah.
Yeah. But the interesting thing I've learned, like, is that the polyhalite is between the salt and the muriated potash, or the potassium chloride. And for years, they never bothered with it because it's only 14% of potash, whereas the muriated potash was like up to 60% potash. So that's what they were mining. But they've now that they've found there's a lot of there's quite a lot of advantages to polyhalite because it doesn't contain the sodium ions. It contains, instead of sodium chloride, it contains, what is it now, calcium and magnesium. So as a fertilizer, it's much better because it doesn't damage the plant. There's nothing in it that damages plant roots like there is with muriate of potash. So although it's lower in potassium, it hasn't got the damaging chlorides in it. And that's the way I understand it anyway.
That doesn't make sense, Doug, really.
Why?
Well, the thing is, presumably they're mining this potassium chloride for the potassium content.
Yes, they are.
Yeah, but the chlorine would be quite toxic to plants. So yeah. I'm a bit surprised, but they don't process that by some, reaction to.
Too expensive, isn't it? They do process it. You can buy fertilizer that's been processed, but it's vastly more expensive. It's 10 times the price of muriate of potash. I mean, I've bought fertilizer, so I know that. If you buy muriate of potash, I mean, years ago when I used to buy it, you could buy muriate of potash for something like, let's say £8 a bag, like for a 50-kilo bag it was in them days. You'd be paying £8 or something for muriate of potash. But if you wanted potassium sulfate, which is totally safe for plants and it doesn't contain any chlorides at all, then you're paying like, 70, 75 quid for a bag for the same weight of it. And that's because it's been processed and they've taken the chloride out of it, haven't they? And replaced it with sulfur ions, and it's a chemical, some kind, I don't know how they do it, but it's some kind of chemical process where they
boil it up with sulfuric acid. And the chlorine goes off as hydrogen chloride gas, and you're left with potassium sulfate. Well,
that's maybe so. There's another mineral actually that they get out of this mine, which it's quite interesting. I'll explain that later on when we get over to the pump. Shall we move on? And right, okay. Where's my arrows gone? Oh, see, I've got them. Les have put me on a bum steer. I can't move it at all now. What have I done? Let's just see if I can move this. Why won't that picture move?
Because it's static.
Static. No, I've lost it. I've lost the ability to. Oh yeah, right.
Oh yeah, you have to minimise it.
That was it. Yeah, I bloody hold on. Let's just make this. I can't make it a bit bigger now. Anyway, that's the same coal cutter there, and the same type of machine that the other picture was, but it's this is the front of it. The other one was the back. I still can't find out. Oh yeah, right. So where's the arrow thing on there? Put that
the other side of the bar.
Okay, we're on. Yeah. Right. This is where this is like. Can I make that a bit bigger? Why can't I do that now? Because why does nothing work?
Click on the plus. Click on the plus, and then drag the bar across underneath.
Where's the bar? I haven't got that.
Blue thing. When you click on it.
Yeah, I know, but the blue thing.
Blue thing below it.
It's not there.
There.
Where?
We can see it. The little blue line.
On my screen.
It's not on mine. Oh, never mind. I don't know.
You're in arrows now.
You're in arrows. What the hell's going on now? Oh, hang on. You're in annotate or something. You're in. How do you do that?
Oh, that's what. Yeah.
What that?
I don't know how you turn that on and off, even, Doug.
I've done something now.
Hang on a minute.
Stop editing it. That's an edit pencil.
You're draw something now, Doug.
I don't know what I've done.
You're in annotate mode, and I don't know how you turn it off.
Click on view options.
Yeah, at the top.
Scroll down to annotate, and when the annotate bar comes up, you can first of all choose the rubber and rub off all your blue arrows.
Right.
And then you can choose the X at the end.
I might
Clear.
need to rub out the arrows.
I can't. Where's view options?
Well, maybe
At the
that's
top.
Stop video, mute participants, share, pause share. I haven't got no view options. Hang on.
Very, very top of the screen. Put your arrow at the very top of the screen.
He might not be able to see that because he's sharing.
Oh.
Yeah.
Pause share, participants. Anything here?
I wonder if it's worth you just stopping sharing and reshare again, Doug.
Yeah, let's try that. Right, okay.
You know, when you do share screen, do you not get an option to screen one?
I don't know, to be honest. Let's have a look.
What comes up? Because I think you share an application.
Right, okay, we've got that picture back
Go on
now.
then. You're right. Yeah.
Let's see what happens. Shall I just have a look if it will jump again? Oh, there. Look, the thing's there now. Right.
Hey, that's it.
Right. So this is the potash, and they've left a stall there. You know, a pillar and stall type of thing. This was the old type of mine, and they don't do that anymore. But anyway, move on.
So what do they do if they don't leave that pillar there? What happens? They've got to leave that pillar there, haven't they?
That's John.
They what?
They cut it like coal, so it's a retreating face. We let it collapse.
Yeah.
Oh, right.
They put roadways, which they use all the time, backwards and forwards, and then they like Les says, they just let it collapse once they've mined it. You know, they've had a few accidents actually by using that process, but I suppose they must have had accidents before as well. This is the car that takes the mineral from the face. That, you know, that cutter drops it into this, and then this takes it to the shaft bottom. They have these in coal mines, but they don't use them the same. Most coal mines have a drift now with a drift conveyor in, don't they? So that would tip it in onto the drift conveyor via a chain conveyor to sort of slow it down. But here they tip that into a chain conveyor, which feeds it onto buckets that go up the shaft, which is quite an old way of working really in mining terms, isn't it? But they haven't got a drift, so, and it would, it wouldn't be cost effective, would it, to make a drift now?
How long, Doug, before you go on, how long would you say it takes to get from the surface to the face, time-wise?
Well, it takes you 7 minutes to drop down the shaft for a start.
Right.
From the surface, when you get into the cage, it's 7 minute ride to get to the bottom of the shaft.
And that's going pretty quick as well.
It's going at a hell of a speed, yeah. But it's going 1.1 kilometers, like, isn't it? Yeah. So, it's a hell of a death. I mean, if you think of 1 kilometer running it on the surface, it's a fair old distance, like, isn't it?
Yeah.
When you think of that vertically, like, yeah.
It's impressive, isn't it?
This is the mine at night. Quite nice, isn't it? And this is one of the minerals. This is
poly. Is that a ship, is it?
No, I think it's just a hopper that they drop it into. These people are in. These are the bunch that work in the lab. I've got, these pictures are a bit mixed up actually. I should have explained that before. This is the dark matter lab, and they do quite a lot of things there. It's quite interesting.
The dark matter that doesn't exist, Doug?
Well, yeah, I don't think it exists personally, but they're still looking for it. What they're looking for there, the main experiment that they've been doing for years there is they're looking for what they call WIMPs, which is weakly interactive massive particles, isn't it? Which is a theoretical particle, which is supposed to account for 90-odd% of the universe's matter. Personally, I don't believe it, but then, nobody's convinced me yet. But they're also looking for some particles which are carriers of, which are supposed to carry various forces, which they had a Xenon experiment there, liquid Xenon. They were one of the first places to have liquid Xenon, and I think their experiment, their liquid Xenon experiment, had about kilo or a litre or something, or I think it was a litre of liquid xenon, it's very expensive stuff. And I don't think the experiment ever really came to anything, but they now the sort of, I think there's an experiment in Italy now which is using about a ton of liquid xenon. So they've like scaled it up and scaled it up and scaled it up, and they basically still haven't found anything. So basically what the principle of this lab is that you have to screen out if you're looking for a particle which you're trying to find a weakly interacting particle, aren't you? So the particle, it acts through gravity, but very little else. So they put the biggest experiment in here was it had a tank of very, very pure water. And the idea was that as these particles pass through the water, they'll collide with sort of other particles that's in the water, like, I don't know, hydrogen atoms or something. And then they'll produce a little spark, like a scintillation. And then you have cameras in the tank which find it. But you get too many, you get too much noise when it's near the surface, because you get cosmic particles and all kinds of things, cosmic rays and things that set it off. So you can't tell whether you've seen one or not. So they put this thing a kilometre underground, and then the ground that it has to pass through is supposed to filter out all of these cosmic rays and stuff that are, that are interfering with it. And the WIMPs, because they're weakly interacting, they should, in theory, pass all the way through the Earth anyway without any hindrance. But the odd occasional one would interact with a hydrogen atom or something like that, and then it would be detectable. For me, I personally don't wear it, but that's the theory of it, isn't it? So there's other interesting things go on there as well. These are the miners, or a bunch of people going down. I suppose I don't know if they might not be miners. This is another thing that goes on in the laboratory. They're doing work for NASA, testing like Mars rovers and things like that. I presume because they can get a terrain that's a bit Mars-like. I don't know why, but they do. Apparently, they've got quite a good contract with NASA for doing stuff, and that's one of the things that they do there. That's the mine in the daylight, the surface, obviously, and that's where it is. This is where the mine itself is. The surface work, the surface works, but most of it is out there under the North Sea, isn't it? When they say it's 1.4 kilometers deep, that's out under the sea, isn't it? The actual shaft is 1.1 kilometers, and the mineral deposit inclines away. So the further out to sea they go. I mean, the mineral goes right across the North Sea and beyond, right well into Europe. But at this point in the North Sea, it declines that much that it's becoming too deep to mine now. So,
what was it, Doug? What was potash? That's good, tell us.
What's
Where did
that?
potash come from?
It's an evaporate.
Well, it's evaporated sea, isn't it? It's just an ancient sea, but it's an ancient sea which is evaporated away.
It was a Zechstein Sea in the Permian.
Which what was, sorry?
The Zechstein Sea,
yeah,
which actually extended across part of the North Sea and northern England, the Cheshire Plain. All your salt areas were in the Zechstein Sea. So if you think, well, Winford and all that around the Cheshire Plain, if you think about that whole area, the rocks on the surface there are red because it was a desert. Mm-hmm. And the sea grew and shrunk as the temperatures changed and the water input and flowed in and left. So there's a whole series of cycles where the sea evaporated away and deposited the minerals, and then the sea got back in again and replenished it and went through a whole series of cycles. This is our oil reservoirs, the stuff where Tim's working. All the oil's trapped under it.
Yeah.
Yeah, it goes, and it was the Zechstein Sea, and from what 150 million years ago when it was actually deposited.
Yeah.
So you know it's like 1.4 kilometers underground.
Yeah.
How that's obviously the deepest part of the mine, but how deep is the shallowest part of the mine? You know, is it quite a wide seam?
Well, the shaft is a 1.2.
Yeah, the shaft is 1.1 kilometers, and they ended the shaft at what was the mineral at the time. You know, when they started mining it. And
so is there no mineral above that height, sort of thing?
There's mineral above and below it, isn't there? But you know, the mineral that they're looking for at the time, they wanted muriated potash, didn't they? That was the mineral they were after. So they went down into the salt. Well, they didn't really at first, because it took quite a few years to discover how weak the potash was. So they had lots of accidents where they had, roof collapses and things. When they used to mine it as pillar and stall mining, they had a lot of accidents there. And then they discovered that it was much better to drive the roadways in the salt, which is much stronger. It's a much stronger mineral than the potash. So, once they discovered that, or they sort of worked it out that it was best to do that, they started driving all the passages that they were all the working tunnels in the salt, and then just driving up into the mineral they wanted when necessary, and then sort of spending as little time there as possible, and then getting it out and leaving nature to its own. Like
to answer the question about the minerals, there isn't anything of much use to them above the potash. You've got 100 million years of deposition above it. If you think about where you are, you're in the North Yorkshire moors. So you've got on the top, on the surface, you've got basically Jurassic limestones. And then as you go down, you've got a series of clays and stuff. And then you get to the salt and the potash beds.
Yeah.
And that's just how deep they happen to be. So
is there only one shaft for all them workings?
Two shafts. There's a man shaft and a main. You can use both for bringing people out if necessary. But the mineral shaft that they use to haul the mineral up, and then there's the sort of the man riding shaft. Like
I think there's a legal requirement to have two shafts, isn't there?
Pardon?
I think there's a legal requirement to have two shafts in.
Yeah, probably. An interesting thing as well, though. Oh, sorry, go on.
The interesting thing is that, obviously working at the faces now is very, very hot and not particularly pleasant. But you would have thought they could actually pump water down and pump the resulting brine.
Well, that was one of the options when they first sank the mine. When ICI sank the mine, that one of the options was that they would do it by dissolution mining. Is it? They call it solution mining or something, where like they do in Winsford, where they pump water in and pump it back out again, and then they evaporate. They pump it to Runcorn and they evaporate it there, don't they? And that was an option at the time, but I think it wasn't practical because at the time, anyway, this was in the 1960s when they were considering this, wasn't it? And it was by the time you got the contamination from all the minerals that you would have dissolved unintentionally, and then you've got the cost of evaporation, they decided it was cheaper to mine it physically. It might have changed now, mightn't it? Because
it hasn't changed much, Doug. He has it there. Going to do a new mine, so
yeah, that's true. Yeah.
The other issue you've got is you're not going to brine pump right out under the sea, so you're only going to get the mineral that you can get on the land.
Well, I have heard that there was a plan to brine pump out, out beyond where they've mined so far. they were talking about boring into that.
What horizontal?
Deposit. And you know, like they do for fracking, where they do this horizontal boring and then pump and brine pump it. But even then, you know, it's such a long way to pump a liquid. The cost of pumping it is pretty phenomenal, really.
I'm surprised they haven't run a roadway conveyor to bring it out. It's obviously the quantities they're moving are too low to actually make it cost effective.
Well, I mean, in a coal mine, that's what they do. I don't know why. I mean, I've worked in lots of coal mines, and that's the way they do it. You know, they just extend conveyors in. But, you know, you have to keep, the problem with that is you have to keep extending the conveyor, don't you? And in coal mines, you know, there's very few coal mines. Well, there's no coal mines, I don't think, as deep as that, is there? So, you know, it's pretty hot down coal mines, you know, some of them, isn't it?
I'm going to guess all the metal isn't going to survive very long either.
Ah, that's where you'd be wrong, you know.
Yeah?
Yeah, absolutely. There's no rust whatsoever. It's unbelievable because the whole place is surrounded by salt. It's hygroscopic and it draws all the moisture out of the atmosphere. It's the driest atmosphere you could get anywhere.
Right.
Yeah, it's like that down in the salt mine because my brother-in-law works at Winsford in the salt mine. I've been down there with him a few times.
I mean, you down there in the mine, you're driving round in Land Rovers and not Land Rovers, Transits, and they're like new. They're pretty old. You know, they're old type Land Rovers, old type Transits, and yeah, they. You know, I had a Transit and I had it for 10 years and it just disintegrated eventually through corrosion. These were older than mine and they were like new. You know,
what my brother-in-law was saying was when they bring them to the surface, if they bring anything like that to the surface, within like a month, they're covered in rust.
Yeah, there would be, I suppose.
Yeah, because the salt is still sort of ingrained into them. But as you say, there's no moisture down there or whatever. And they don't rust underground. But as soon as you bring anything to the surface, it rusts like mad.
Going back to the solution mining, the one advantage they would have there is the fact that because the rock down at that level is quite warm, I mean, 50 degrees, the solution you will get will be very concentrated. And when it comes out, it will be hot. So if you do that straight into a vacuum evaporator, your costs of recovering the solid from the solution is going to be actually quite low. Yeah,
maybe so.
But they still haven't considered that for this new mine, have they?
No, they've.
I mean, I'm imagining.
Well, they must have thought of it, like, mustn't they?
Well, yeah, but given that they're planning to drive a tunnel 30-something miles all the way to Middlesbrough, from the national park.
Yeah,
and then mine it in the conventional way. We're obviously missing a bigger bit of the picture as to why.
Yeah, there must be
pipe mining doesn't work for them because
it's a coal mine, Les.
Sorry,
a new coal mine.
No, a new potash mine.
Polyhalite mine it is.
Yeah.
Oh.
Yeah.
Is there a new coal mine opening?
That's Whitehaven in Cumbria.
Oh.
It might not yet. The government's reviewing their support for it now. Now they got all the flack.
Well, Sirius Minerals might not be opening the polyhalite mine either. The way there's problems with that. I mean, I lost about. I had shares in it. I lost about $3,000.
You might get it back.
No, I won't because it's been sold. It's been. I got 30 pence. I got about 30 pence a share back, but it cost me a lot more than that. Like. Anyway, these things happen, don't they?
A pipeline from the North Yorkshire Moors to Middlesbrough to move the polyhalite in solution would be substantially cheaper and easier to maintain than running conveyors in a bored tunnel. So somebody's done the maths and the solution doesn't stack up, is it?
Another thing you're forgetting there, though, that there's polyhalite is not like muriated potash, is it? It wouldn't dissolve the same. Because it's got calcium in it, hasn't it? It's got, you know, it's calcium.
It dissolved when it was in the Xenon Sea.
Yeah, that's true. Yeah.
It's
but
just it
dissolve it again. I wouldn't be too.
It dissolves better than the rock salt, but less good than the the potash.
Yeah.
Yeah.
Yeah. Anyway,
Doug, there was one of them in America that was solution. I was watching it on the television.
yeah,
They drew it all out, and a smaller hole opened up because of it, 100 foot wide and 600 foot deep. And they got sued. A big company in America doing the same thing. They put it to a solution, and they caused a massive big void underground, and it just collapsed 100 foot wide and 600 foot deep. One of them adventure programs.
bloody hell.
I know. I always watched them to do with sinkholes, and it was amazing. And it was the same thing. They were turning it to a liquid and drawing it out, but as it all went lower down, it created a massive big void, and it couldn't hold up.
I think they've had problems like that around Winsford, haven't they, of subsidence because
You've
of
got the Winsford flashes, but all the houses subsided, and you've got dirty lakes or little, flashes on the surface, and that's entirely down to the ground not being able to be supported after they've solution mined out the salts.
Yeah, it's mainly round like round Northwich, because all the buildings are on timber frames, which were all been jacked up over the years. And the most of the solution mining over in Cheshire is at Lostock.
Yeah.
And then from Lostock Works, there's two big pipelines that run over to Runcorn from there. But yeah, it was mainly Northwich, wasn't it, that sank? And even recently there's been more.
They're much shallower mines, like, aren't they?
Yeah. Yeah, I think the mine at Runcorn's pretty deep. I think if memory serves me right, that's about 150, 200 meters down. I think. Did I have some notes on there? What's upon it? It's fairly deep anyway. But the issue is where you do your solution mining, which was done, well, used to be done in the Northwich area, and it's certainly still done over at Lostock. Yeah. That's obviously a lot shallower. So that's why you get problems with stuff sinking. But the deeper stuff, like at Runcorn and that, that's deep enough that it's stable.
Yeah. Well, another interesting thing about that mine, I mean, if it closes, if this polyhalite venture is not successful, the mine will end up closing, won't it? And if it closes, they might use it to store, this carbon capture business where they capture carbon in stacks and things, and then store it underground. Well, a salt mine is a good place to store it, isn't it? Because it's sealed.
Yeah, that's exactly what they're doing, isn't it? They're doing that.
And, well, it's been considered for Boulby mine, hasn't it? If it closes.
Yeah.
Anyway, we'll move on, shall we? It's a bit of stuff about the. There's loads of stuff about this laboratory on the internet, isn't there? If that's the same picture again, isn't it? This is where these are the workings, aren't they? And that's where the laboratory is, I think, and the rest of this is where the extraction sites are. This is why they're all in little short. They do a short work, a short amount of extraction, and then when the mineral becomes less good quality, they just abandon that and move on to somewhere else. Instead of doing this pillar and stall mining, really, it's just a bit of stuff, like historic stuff about it, and that's been in papers and what have you. That's interesting. Where it's got your depths and your 6.5 kilometers from the coastline. North depth below. Yeah. See there, temperature's 32 degrees C. Is that saying? Yes, 764 meters. And it's 32 degrees C. It's bloody hot anyway when you're down there. It's unbelievable. When I went down there, they give us a whole pack. I don't know how many of us there was. Forget now. Probably 10 or something like that, perhaps 10 people. And they gave us a whole pack of bottled water and said, you'll be wanting that. And we all took a bottle each and put the rest in the transit. And it was gone in about an hour. You know, there was no water left. I spent most of the day dying of thirst. If I'd have known, I'd have took more blinking water with me, because you do need an awful lot of water down there.
They don't do the tour now, you said, no.
Well, they stopped it. They had an accident, didn't they? And they stopped it, but I'm not sure.
A member of the public?
No, it wasn't a member of the public. It was I think they had a fire. What they do, these roadways, right? They drive the roadways, the big wide roadways that you can drive lorries down easily. And you get two roadways side by side with a gap in the middle, right? And for safety reasons, there's two of them. Then there's every so often there's a connection between the two, right? And it's like a passage. So you basically got one going and the other's coming back. But to wherever the main roadway that's going out to the working areas is like a 2-lane highway, and then you've got a wall between them, which is like 20 foot wide or something like that, 20-30 foot wide of salt. And then you've got sort of doorways through that salt that you can drive through. And what they do, because they've got the ventilation system is blowing air down one of them, down one passage, and sucking it back up the other, innit? So these passages are a hindrance to that, aren't they? These openings between the two tunnels, they're all right for safety reasons, because you might have to change from one tunnel to the other, but they're a danger. Well, they stop the efficient working of the fan, the air flow system. So what they do, they fill the hole up with massive blocks of polystyrene. You're talking about polystyrene the size of a bloody house, and they're big, they're blocks, and then they stick them together. They're big blocks. You could carry them, but they're sort of well, I don't know how big they are. They're probably about 8 foot square or something like that. These blocks, and then they build a wall with these blocks of polystyrene, and they stick it together with expanding foam. And then they just fill these big holes in. These holes are like 20 foot square between the two tunnels, and they fill them in with the polystyrene. Well, what happened? One of these bloody blocks of polystyrene caught fire, and then the ventilation system blew the acrid smoke all around the mine, didn't it? And I think there might have been one bloke killed, and quite a few had inhalation problems and that, But after that, they didn't let the public go down there again for a long time, and maybe forever, I don't know. But I think it might be possible to get down there again now. A couple of things I read made me think that you might be able to get a trip down there again. But I don't know what they've done about the fire risk of this polystyrene. Well, there's another interesting thing as well. When you go down there, you're walking down these tunnels. I mean, you drive from one place to another, because you're talking about kilometers, aren't you? So if you're going from the working areas to, if you're going from the shaft bottom to somewhere interesting, like where there's work going on, you go in a vehicle. But then you get out and you're wandering around, aren't you? So you're walking around, and there's a bloke showing you stuff. Well, all along these tunnels, there's a rope along the wall, and if you're in total darkness and you're lost, you find this rope, and if you keep hold of the rope, it guides you to one of these rescue shelter places. There's shelters where they've got stores of food, and there's all kinds of food and water facilities and stuff. And if there's a disaster or something and something happens in the mine, you find your way to one of these by following this string. It's just like a cord, and then you find it, and it's got little cones on it, so you can tell which direction you're going, and you follow the cones, and they point to a shelter. And as long as you keep hold of the rope and keep following it, you'll eventually come to one of these shelters, and they're all over the place. There's quite a lot of them in the mine, but it's quite an interesting thing, really. if you're even in total darkness, you could find your way to back to one of these shelters, and then you're supposed to get in the shelter, shut the door. There's air conditioning and all sorts of stuff in them, you know, to keep you alive until you get rescued. And there's telephones and all sorts in them as well, like. But that's quite an interesting thing. Right, where were we? I think that's the schematic thing of the whole mine. Basically, estimated water level. That was in 2005. There's an ingress of water that comes in. That's interesting as well. There's one place in the mine where water comes in, and there's further along. There's a couple of pictures of the pumps. They pump this water out, and it's basically like solution mining. They pump the water up because they have to get rid of it, so they pump it to the surface. But they don't waste it. They extract from it a very pure form of potash, which I've forgotten what they use it for now. I think it's medical or something like that. It's something where they'd require it very pure, and they get it out of this water that they pump to the surface. So that was just part of, I forgot to say that's part of the conveyor system that they use, you know, to move the stuff around. But they don't move it far by conveyor. It pretty much only goes to the shaft bottom by, you know, they drive it from the production area onto a conveyor, it goes to the shaft bottom, and then it gets loaded into tubs to go up the shaft. This is the different workings, isn't it? This polyhalite seam is the new part of the mine, you know, because all the other stuff is all pretty much closed down now, the muriated potash. It's cheaper to get it from Spain, and they also, this Israel Chemicals Limited, who own the mine, they also get muriated potash from the Dead Sea. I suppose they must evaporate seawater, I don't know really, but they get it from the Dead Sea as well. This is one of them. I'm a bit scared to bloody try and use this thing now. Oh yeah.
Can you expand on that?
Yeah.
What's that, Doug? A drill, is it?
It's a roof bolter. It's bolting the side there, isn't it? But they use it to bolt the roof. They get a lot of spalling if these tunnels, right? It's like a gold mine. There's immense pressure above it, and the pressure's pushing downwards on the walls, and you can get spalling. So what they do in some places like that, they bolt it like just the same as roof bolting to stop it spalling. But I don't know if you can see up.
What's spalling, Doug? Just don't jump on. What's spalling?
The wall just explodes off. You get it a lot in gold mines, don't you? And you know, you don't get any warning or anything. The wall just explodes and kills people. They've had a few deaths in this mine, but it's more common in gold mines that are very deep. But what they do, they've got the solution they have here, and this will be an old tunnel because they're bolting the wall. But up there, see that between the roof and the wall, in the main tunnel, the drives, like they cut a bloody little channel in there, and it's about 200 mil. It's about 200 mil deep, and it goes in like half a meter. And when the pressure is on the roof, it sort of pushes on that instead of pushing on the walls.
Oh, right.
And it takes the pressure off the walls. They only discovered it I suppose 10, 15 years ago now. But the more modern tunnels, they do like that, and they put this on the top, and it saves the spalling by a hell of an amount. That was quite an interesting thing. The fella explains all that to you, like. I think that's just a bit of a schematic thing of the ore body. I think I'm not quite sure what that is. See, that would be the roadways, I think, underneath, wouldn't it? And then the red would be the mineral that they're looking for. This is the sort of car that takes it from the cutter, from that coal cutter thing. It drops it into here, and then that fella's, he's the driver. He's driving it with a little pad thing, you know, with buttons on, and then he'll take that to the face, to the from the face to the, put it on the conveyor to go, you know, to take it to the.
It's a dumper, is it?
It's like a dumper, yeah, but it's a one of them. It's like a hinged in the middle thing, you know.
Yeah,
it's quite an impressive thing. Yeah, it's an impressive thing to see, like, and it's all. Nobody sits on it. He sort of stands there and operates it. He kind of walks in front of it or behind it or whatever, you know. And then this skip thing here is full of mineral, and then he takes it, and it's very very manoeuvrable. Goes around little corners and all sorts. And then that's the cutter, like, isn't it?
Oh yeah, you've gone the full loop now, have you?
Yeah, yeah. I think we've had that picture before, haven't we?
Yeah, that was on for about 4 days. That one, wasn't it? It felt like it.
Right. So there's a bit of was a bit of a interesting thing. That I forget what that was.
It's a tunnel, that.
I know it's a tunnel, but I forget what all the steel work was for.
Stole the roof up, mate.
Well, this is what the tunnel, most of the tunnels look like. See, these have been roof bolted, haven't they? These side mesh ones. The ones where there's a lot of traffic, where there's a lot of work going on, they'll have them all bolted like this, you know. But you can go for miles with none of this stuff in the.
Just cut into the salt, is it?
Yeah, it's just cut into the
just salt walls.
But up there, they'll have that little groove, and that's to stop it spalling. See, you get a lot of you see when you're driving along in there, you see a lot of places where the walls have spalled, but nobody's been there at the time because they you know, because of the traffic is just vehicles driving up and down. You wouldn't walk kilometers like that. You'd be in a vehicle, like, wouldn't you? Yeah. And now and again, you'll come to a place where you've got to drive around a heap of shit that's on the floor, which is spalled off the wall. But if you'd been standing there at the time, you probably wouldn't know about it, like, would you? This is part of the laboratory. I've got these pictures all mixed up, haven't I? This is something going on in the laboratory. We're not sure what, to be honest. They let you in part of the laboratory. You know, where to walk around in it, not in this is a clean room thing, isn't it? But you know, you couldn't go in them sort of places, but you can go in and have a look. You can go in the main sort of building, and it's like a building inside a cavern, isn't it? You know, that you're in a salt cavern, and then this building is inside it, and you can sort of walk. You can go in the canteen and places like that. You know, where the public areas type of thing of it. You know, they don't let you see any of the fancy experiments or anything, but it's quite interesting to look at. Like, that's I don't know what else you can say about that. This conveyor, they had a fire in it last year, I think. Quite a few fire engines there. Apparently, it was on the news and everything. This is salt that they, you know, this stuff that they just tip on the surface is just road salt.
There's a fire engine there now, Dougie, in that picture.
Let's have a look. Aye, yeah. Well, maybe that was the
fire.
Yeah, I think I lifted it off some report about a fire there. That's probably one of the pictures I got off it. Yeah, there's lots of places like this, sort of quite big caverns where stuff goes on, you know, storage and things like that, you know, and there's workshops, there's all sorts of stuff, like, you know, that are interesting. This is a historic picture of the shaft bottom, and this is an old picture that probably goes back to ICI's days, I think. And I think that was the shaft construction in ICI's time. That would have been, I mean, I think the mine opened in the 1970s, the early 70s. So I think this construction would have been in the 1960s, wouldn't it? Took quite a long time, I think, to sink that shaft.
It's an old Ruston Bucharest, that, isn't it?
Yeah, probably would be, I should think. Yeah.
First shaft was.
How do they get transit vans down there then, Dougie? Are the cages that big?
They drop them down vertically. They strip everything off them. They strip everything down to basically the chassis and all that, and the cab, and then they lower them down head first. That's the only way they can get them down the shaft. I think they lower them under the cage. They can lift the cage higher than, you know.
Yeah.
And then they hang them underneath the cage, and then they lower them down the shaft. And when they get to the bottom, they put a few things back on. But when you get in them, there's no fancy console or anything like that in them. You know, there's basically a seat. They take everything off them that the van doesn't need. And I don't know how they go on with these modern ones, like they've got all bloody computer controlled in them and that. But they're all old transits. They were. Well, not that old, like, but you know.
Well, they don't need any modern ones if they don't rot away.
No, they don't. This is the winding engine for the main shaft, isn't it? Beautiful thing, and you can see it going as well when you get a little tour around this. Dead interesting.
Proper place, isn't
Yeah.
it?
It's a gorgeous thing to see. That is. Mm. And then you know when the cage is going, you see this thing spinning, and I mean that red bit doesn't spin, but you see the bit that spins. You can.
Be good to have a trip here, Doug, wouldn't it?
It would,
You know, if it does open again.
Yeah. Well, I'd be up for it. Like, I'd definitely be up for another trip there, especially if it might close. You know, there's a chance it might close. So if this polyhalite experiment doesn't work, I think they'll probably shut the place. These pumps, this is a smallish pump, but you know, I said before, there's an ingress of water in part of the mine. There's a pumping area. There's only one pumping station in the whole mine. I think it's in the middle of the mine, and they pump this brine out, which is seeping in from somewhere, and they pump it up, and then on the surface they sort of purify it into a product. So it's I don't know, it might not be worthwhile, but they've got to get the water out anyway, haven't they? So they make use of it. Like it's quite good, really, quite clever, isn't it? There's two of these big pumps like this one. He did tell me what they were called, but they're very powerful. I mean, look at the size of the motor; it's pretty big, isn't it? When you look at the size of the pump, the motors must be pumping a fair pressure, mustn't they? And there's two of them, and then there's loads of smaller pumps, and they just pump that up to the surface and then do something with it and make it into some special, very expensive form of potash, which I'm sure they said that it was used for medical purposes or something. This is another bit of.
That's through the salt ladder, is it?
No, that's muriated potash. The salt is more of a greyish colour. The potash is red there anyway. But I've seen when you buy muriated potash, sometimes it's red and sometimes it's grey. I think it just depends what it's contaminated with. It's the actual potassium's not that colour at all, I don't think. In fact, I've got some samples here. I'll show you in a minute, but I'm going to get to the drilling bit because that's
that large bore pipe on the left on that last one. That yellow large bore pipe. That's ventilation, is it?
I don't know, to be honest. Probably because it's a soft pipe and it's nothing. It's not taking any pressure. I don't know what it is. But that passage there, it's an old type of passage, and they don't mine it like that anymore. But there's loads of, when you sort of get in there, you see it's a bit like you can see all the way they've changed their mining methods over the years, and used different machines and stuff. This is the shaft bottom, isn't it? I mean, when you get out of the shaft at the bottom, it's quite cool, and you think, bloody hell, what they were on about, just telling me it was hot down here. And then, you know, when you get like 20 foot away from the shaft, you're like in a desert, you're cooking, you know. But this is the potash, and this is one of the old stalls, I think, where they used to mine it. You can't go in there; they won't let you go in there, but they let you have a look in. It's quite.
That's stone on the floors. What's on the ceiling there?
Yeah, it's spalling, I think, that off the walls, because it's more prone to spalling than the salt is. But it's basically just like rock, you know, and it's like I say, I got the pictures all mixed up, haven't I? So I should have shown that in the beginning or earlier on. That's interesting. This is a thing. This is telling you what's in the polyhalite compared to what's in the muriate of potash. See that potash is water-soluble mineral containing potassium ions, and polyhalite is a water-soluble material having potassium, calcium, and magnesium ions. That's why it's so much better as a fertilizer, although it's much less concentrated in potash. It hasn't got these bloody potassium ions in it, has it? And there's not these, chloride ions that are bad. It's like it's got sodium in it, hasn't it? That sodium's bad for plants as well. Mainly chloride. And, this is about world production, like in it, not Boulby's production. Sedimentary marine evaporates. That's basically what the interesting, though, isn't it? That's the mineral. That is muriate of potash, and that's a bit of it there. Can you see that?
It's like copper mineral, that, isn't it, Doug?
I suppose it is. Well, it's if you lick it, like it tastes like salt. But can you see that? That's a piece that I got from Boulby mine.
Oh, yeah.
Just a piece that picked up off the floor, like. But I've also got here. These are core samples. One of them. Where is it? Right. That one is potash. No, sorry. That one, the one with the red in it, is potash. Can you see that?
Yeah.
That's a piece of a core sample. There's millions of these all over the floor in the drilling place, in the drilling chamber. And they basically take all the cores out, and they choose the ones they want, and they throw the rest on the floor, and then they just scoop them all up. And they say, you take them as many as you want, like, but you don't take too many because you've got to carry them around with you, haven't you? But that's salt, that is. That's a salt core, which is like the rock salt, basically, that they use for the road. That was quite an interesting little foray. Now that is polyhalite. That's the difference between, see, that's muriate of potash, very concentrated potassium, isn't it? And that is polyhalite, which has got calcium, potassium, and magnesium in it. So, and it's a much stronger rock as well. It's more like the salt, if not stronger than the salt. So, that's what they're mining now. And if the mine stays open, that's what they'll be mining from now on, isn't it? Now this is interesting. This is where there's a chamber, right? There's more than one of them in the mine, but this is where they do the exploration to see what what the reserves are in places they haven't mined yet. And that's a drill. It's a horizontal drill, right? And it's in a chamber. They dig a chamber out, and then they put this drill in it, and it's on a swivel. So they drill a hole in there, That's the hole, right? And they drill that hole 3 to 4 kilometers long, horizontally. It's amazing. And then they take core samples, you know, they drill all that. It takes days and days to drill that hole, like, doesn't it? But then that's spinning round, and you can see it spinning round. You can talk to the driver and everything. And they take the cores out. Every now and again, they withdraw it, take the core out, and they send it back in and all this. And it's got some kind of, they send a probe in. They take it out, they take the core out, and then they send a probe in that measures, it knows exactly where it is in space. So if it's gone up, it'll know, you know, if it measures the incline and everything, and the side to side, it knows exactly where it is in space somehow. And then the fella can see that on a computer screen. And then if he wants to go up, he sends it up. And if he wants to go down, he sends it down. And otherwise it goes more or less straight. And I said to him, how the bloody hell can you...
It's different speeds, isn't it?
When you're talking about a drill 3 kilometers away, how can you make it go up? And he said,
different speeds, speed it up, yeah.
Yeah, he said, all you do is, if you want to go down, you slow it down.
Yeah.
And if you want to go up, you speed it up.
It's
and
wild, isn't
it? Me ever since. I've still not fully understand how it works. But saying that, there's water is pushed down the center of it. So there's water coming out of the end of it somehow, and then the water comes back down and they collect it at this end.
Nice.
So I'm pretty sure the water has got something to do.
Pressure, yeah.
How
did he get it to go left and right then?
I don't know. He didn't know that either. I asked him that, but he said he doesn't worry about that. Like it.
Only work here.
Yeah. Well, that was his attitude pretty much. Like, you know, he said no, because I said to him, how does it go up and down? How can you make it go up and down? And he said, well, if you want it to go up, you speed it up. If you want it to go down, you slow it down. So I said, well, how does that work? And he said, no idea.
That's no different.
It's probably the cutter, the way the cutter is fabricated. It may be that it will actually have a differential element which allows it to, if it's set at a constant speed, a particular speed, it will actually cut uniformly. But if you slow it down, there's more drag on one side and it starts to bend down. You speed it up, it's sort of the opposite.
Yeah, well, what I thought was that it must be the actual drill, the tip, is running in a little chamber of water, isn't it?
Yeah.
And I thought if you speed it up, maybe it's like an aerofoil type of effect where it pushes it upwards, you know, and sort of grinds into the roof instead. And if you slow it down, the weight of it makes it cut into the floor. I don't know, but
this is no different, Dougie, to how they drill oil wells and steer the well off.
Yeah,
fracking and everything.
It's impressive, though, isn't it?
Yeah,
it is impressive that you drill around corners.
Tim works on an oil rig, doesn't he?
Directional drilling, there's all sorts of different techniques, and as you say, I mean, some of it works that the head, because it's not just one cutter on the end. You might have 3 cutters or more cutters, 4 cutters, 6 cutters, and you can adjust the speed independently. So on the modern ones, you can adjust the speed independently at different sides of the head, and you can literally steer it in 3D. I mean, we go literally many.
Why are you making this complicated? It's just like a human being. If you go slow, it goes down. If you go fast, it goes up. It's logic.
Just makes it lower the tone. Anyway, what this really interested me. I was fascinated by it. I spent ages in this chamber. And
what's that on the walls, Doug?
What?
That's just the cut.
Is it what?
That's just the cutting head, the marks made by the cutter.
Yeah, the striations there.
Yeah.
That's the cutter.
Oh right,
you know,
that's the actual rock face.
Yeah, it's like the coal cutter that's done that.
Oh right.
And these are like rails or something bolted to the wall. I suppose that's in case they get spalling in there because there's people working in there. And I think it's just like roof bolting, you know, to keep the walls safe. But basically, what interested me as much as anything was they can drill a 4 kilometer hole with that drill, right, horizontal. And when they want to go up, they turn it up and they turn the drill up and they pour into the potash, because they're drilling in salt now, aren't they? This level is salt. So then every now and again they turn it up and they drill into the potash and they get a sample of the potash, and then they withdraw it down again, and then when they go back in, they carry on horizontal again and they go to the next body of potash, and they sort of they keep going forward and taking samples of the potash, which is above the salt in it. So the drill's going up and down as they want to, and then they get their sample and withdraw it and everything, and then they carry on in the salt to the next place. But the interesting thing is that when they've done this hole, and they've done this 4-kilometre hole, and they've taken all the strings and everything out, then this thing turns round. They turn it a few degrees. They drill another hole at the side of that one, and then that goes off, and they end up with like a fan-shaped. He has it on a screen, you know, so you can see all the holes that have been done and the ones that they intend to do, and that, where they want to take samples. So they get a fan 4 kilometres away from this chamber in, you know, not 360 degrees, but quite a big arc, and they have samples from all of that, and it's amazing. You know, they know exactly where the ore is, you know, and it's really interesting. I found it very interesting anyway. But, this is the end of the tube, see, with the water coming back out of it, and he's drawing that out. That's without he's took the core out, hasn't he? The core's out, and he shoved that back in the machine to go back in. Really interesting.
Is there actually a core coming out, or is it just all wash out from the drilling's wash out?
No, it's core. They take a core out. See what they do? They send it in when they want to take a sample. They send it in, and then they withdraw it, take the core out, and then send it back in again. You know, so there's tons and tons of them cores. I should have. Wait a minute. Yeah, yeah, there's pictures of the cores somewhere. I've slipped up. That was, I just did that bit of a drawing because I was to explain the tunnel shape. That's lying on its side, obviously. Hang on, you can rotate that, can't you? That's basically the tunnel shape, isn't it? And the reason for that is, like I was saying before, the pressure coming down from the roof. With the old tunnels that were square ended, the pressure would make these walls spall and and sometimes kill people because there's no warning. They just blast off. The wall just explodes on you, and if you're standing there, it can kill you, can't it? So they started doing this quite a while back now, but they started putting this cut in the top, and they'll show you that. I think they start off at 200 mil, and as the roof is coming down, that closes up until it's gone, basically. So you can tell how much pressure there is on the roof by how small that gap has gone. You know, if it's getting a bit dangerous, then that wall, that gap closes up, and they know, if it gets down to like an inch or so, they'll cut it again to make it safe again, because the roof pressure is pushing down on the walls, and that's where the danger comes from, spalling. And you can see the result of spalling all over the place when you're driving down the big roadways. There's a core there. That's one of the cores. This is a salt core, isn't it? Because it's the greyish colour. The redder ones are the potash.
I guess they're geologists have then got a 3D model of where all the potash is.
Yeah.
So they know how to direct the drives and everything.
Yeah, that's it. They sort of assess the quality and everything. They'll take samples out of these cores, and then the geologists are there. The driver's just taking the cores out, isn't he? And the geologist will come and have a look at them and say, "We'll take that one and that one and that one," and then they box them up, and then they take them up to the lab and they examine them and stuff, don't they? But quite. That's I done that little bit of a sketch because that's what that drill is like. The drill swivels like that, and like it'll drill that core 4 kilometers, and then it's withdrawn, and it'll drill that one 4 kilometers. I mean, they drill like a few meters, and then they withdraw it, take the core out, don't they? And they carry on like that, and they keep taking the cores out. But basically, that's how they do it. And then they get a fan of the whole area all the way round the mine, 4 kilometers away, and then they know where to, if the quality of the product's not worth going, they don't mine it, do they? They don't make tunnels unnecessarily, basically, do they?
Ian's bedtime.
Oh, right.
That last picture looked like something you should have shown the doctor, Doug.
Yeah, I suppose you're right. Yeah. These are just random cores, aren't they? That is muriated potash cores. And they, see this, there's clay in it and all kinds of things, and they take that into account. If there's a lot of clay, they don't want it, so they, they're looking for good quality stuff, aren't they? And they basically only mine the good stuff. So, cores of, I don't know what they're at, but they get into rock sometimes as well, don't they? And they don't want that, do they? But I think there's pockets of rock in it and all sorts. This is the drilling chamber where where that drill is. I was fascinated by it. I was like, but in where they've took the cores out, there's bloody big piles of them on the floor, and the fella just says, "Well, take them as many as you want. They'd all scrap them." So that I would have took bloody sackfuls if I could have carried them, but it's quite a long way from the shaft, and then
put them in someone else's bag.
Yeah, you would have done that, wouldn't you?
Yeah.
Yeah. This thing just takes this. I think it's like a sonar thing, like a sonic thing. It sort of gets an idea of what's above.
Was it measuring the integrity of the ceiling to see if it needs rock bolting?
Yeah, well, I think that might be part of it, because they do rock bolt. This is where what they do with the ceiling if it's dodgy. They only put this mesh on in places where they're working, or where there's a lot of traffic. But when there isn't traffic, it's basically just the bolts like that with a plate on. And then that's the roof bolting machine. Well, that's one of them. There's a bloke stands there operating that one, but there's another one where they sit in it as well, like, and he's more automated than this. This one here, they sort of put a bolt in it, and then it drills. It kind of drills the hole and then shoves the bolts up and what have you.
How are they putting the bolts up with resin?
Are they resin bolted?
Yeah, I think this is more of a manual way of doing it, but they have a machine that drills it and squirts the resin, and oof, bloody hell, I got the cramp.
Yes.
It squirts it sort of fills the hole, puts the resin in, shoves and the whole thing is semi-automatic, and it shoves the bolt in, and it tightens screws the thing up, the nut on it and everything.
Yeah.
Quite fast acting resin in some of them, because I was surprised how fast the resin could go off. The fella said they've got different resins for different jobs, So that's quite interesting. This is a bit of the stuff going on down there. These fellas did it. They ran a marathon in Boulby mine at 26 kilometers, miles, wherever it is they do. Is it 26 kilometers a marathon? Eh?
No, it's miles and 26 and 26 and a half mile. Is it?
Well, whatever it is, these fellas did it underground at 30 degrees C, so that'd take some doing, wouldn't it? You know, I think they just ran round and round some tunnels, like, but it's a hell of an achievement, isn't it?
Yeah, I don't know why they're running. They must have missed the bus.
Yeah. But there's a lot of community stuff goes on in Boulby Mine. They do, they take an interest in the community. This kind of stuff goes on, and I think they have like this, cadets go down there and things.
Yeah, as much as it looks like they're doing it for the community, I expect it's like a lot of these things where they need the community on side, so they give a positive, take a positive position in the community, and then the community values them. So when
I suppose
goes to planning and stuff like that, they don't get too much trouble.
Yeah,
well, it's actually just a marketing campaign, really, isn't it?
Yeah. But if you've got a local community on site, you can do anything. You know, they're opening a coal mine in Whitehaven. Who'd have thought they'd never open a coal mine in this day, but they've got the community on side.
Yeah.
Well, not open yet, though, is it?
Hey?
Yeah. It's not open yet, though, is it?
No, but the point I'm making is, if you get the community on side, you get them fighting your corner against the powers to be. You're more likely to get the things you want.
Yeah.
Well, in a place like that, particularly, it's mass employment, isn't it?
Well, just up the road from Boulby used to be Skinning Grove, a big steelworks, all gone now, isn't it? Mostly.
Yeah.
So there's very little employment there, and it's in the depressed northeast. So jobs are really important.
Well, see, Boulby Mine have just shed about 600 employees, haven't they? Because this changeover from muriate of potash to polyhalite, it's meant they've needed less of a workforce, like, hasn't it?
They've also got quite a lot of competition in places like Canada, which can extract it cheaper, I guess.
Yeah, well, I think that's been their main problem, because they're extracting it from such a depth.
Yeah,
it's hard to compete with shallower mines, like, isn't it? And I think
serious think they can make money out of it still, though, don't they?
Yeah, I think.
Folks, can I just interject there?
I think polyhalite is not as common worldwide, is it, than muriate of potash? I think it's a much more rarer mineral. In fact, I'm pretty sure that it doesn't exist anywhere else except Britain.
Yeah, well,
you know, I don't think polyhalite, as it is, you can mine it anywhere else. So they probably got the market cornered, haven't they?
Well, I guess so, yeah.
Can I just interrupt? I'm going to bed. It's way past me bedtime. And Doug's brilliant, first class thing there, slideshow. Thank you very much. Enjoy the rest of it, everyone. Good night. Good night.
Cheers, John.
Don't forget my 20 quid, John.
It's in the bank. It's in the bank.
Yeah, we'll make sure it's in mine soon.
In the bank.
Well done, Rob. Well done, Rob, for winning that.
No worries.
Take care. Good night, everyone.
Good night.
Les, best wishes for Wendy.
Yep. Cheers, mate.
All right, matey. We're all thinking about you.
Thank you.
Take care, everyone. Love you all.
John.
See ya. Yeah, when you go.
Has he gone yet? We talk about him.
Yeah. Well, you talk about
I'll come back if you do.
Like a disease.
He gone.
When you go in there,
getting paranoid.
Yeah. Probably will come back in a minute.
Yeah.
You get issued with a lamp and stuff and a helmet. You can't take your own stuff there.
It's not an explosive mine, though, is it? But
no.
That's MSRs on the top.
Is it?
Yeah, those little cans.
Yeah.
Oh, your mine safety respirators.
You've got to carry one of them. Yeah.
Yeah.
They give you one of them. You have to carry one of them. I think it's probably. I mean, I don't think there's anything really toxic down there, is there? Except, that fire they had when the polystyrene caught fire.
That'd do it.
that wouldn't be, yeah, you know, you start getting burning polystyrene fumes spread around in the ventilation system. I think that's probably, and I think that there's a certain amount of radiation as well in potassium, isn't there?
Yeah. I think the MSRs are just because mining regs make them have to do it.
Yeah, I suppose so.
We had the similar thing down here. We were going to organise a club trip into one of the stone mines that was being used as a naval store, and they were going to have to issue us MSRs to go in there. It's a bloody stone mine. It's
yeah.
Yeah.
Anyway.
I would imagine radon levels down there, if the fan system failed, will go up quite quickly.
Yeah, probably.
Depends on where the radon's coming from, though, Dave, doesn't it?
It does, yes.
You have to have a radon source, so you need uranium, which is everywhere, but you're going to need some uranium somewhere to give you quantities of radon, aren't you?
Yeah.
I don't know. I guess there is radon in there, but I don't know how hot the area is for radiation.
Yeah. Well, I think potassium is a natural. It's an isotope, isn't it?
One of the isotopes of potassium is radioactive, but
yeah,
your radon comes from uranium decay.
Yeah.
And the uranium is normally an organic matter, so the chances are that there are probably darker bands in the rock that might contain uranium in concentrate. But...
Yeah. Well, they had they had someone killed in Boulby mine not long back, didn't they? With a gas, a pocket of gas exploded in there or something. It didn't explode, but I think it burst out. A pressurized pocket of gas. Sort of. They mined into it or something and killed someone, didn't they?
Oh, that's all our oil and gas is under that halite.
Yeah. Anyway, I think this is some of the salt they produce as well, the different grades of it. And they do a lot of rock salt here as well, don't they? And this was interesting. This girl, she is a blacksmith, and she's made, I think it's on display in is it somewhere, one of the towns in the area. She made like statues of the masters and stuff. A kind of you know, anyway, she made these iron linking things. That's one of them. And she made all the, like the equipment of the day. I think at the time when the mine opened and stuff. That sort of era, you know, and she's made all these. It's dead interesting, quite nice, isn't it? She's made all this out of steel. Clever. That's the telephones and stuff like that, you know, that they would have used. I think this was like going back to the time when the mine opened. Good, like, isn't it?
Mm.
What's this now? That's a cutter again, coal cutter in it. But I think this is pretty much the last of the pictures now, because I got this picture when I was down there. You weren't allowed to take any photographs. But there's people who have took photographs, and there was a woman who had a trip down there. You know, she was a photographer, like, but I think she was an official photographer, you know, and I think this is one of her pictures. And I obtained a few at the time because I wasn't allowed to take any. I think this is probably one of hers and all. So this is like where we were sitting to have a break, you know. They sort of they were these miners at the time I was down there, they were getting about £1,000 a week, and they had to work 20 minutes and then have 20 minutes off, you know, and they walk around with buckets of blinking water hanging off them and iced water, you know. And I thought, bloody hell, I wouldn't mind a job here. you know, for the money that we get, like. But I think it's changed a bit now. They not as I don't think they're quite as free with the money now because they're having hard times. This is one of the chambers. See them? That's like the polystyrene that they block the holes up with. They have these chambers, and they have bloody big, massive blocks of polystyrene. And they stick them, you know, where the two tunnels are. I've got a opening between the tunnels. They block it up with that polystyrene, and it's all stuck together. It's like building blocks, you know. They're stuck together with expanding foam, and they just completely seal it. And then, of course, you know, you could drive a vehicle through it if you wanted to break it open, but it sort of maintains the ventilation system, like, doesn't it? It keeps, you know, so that the air goes down one tunnel and back up the other. See these areas where people where stuff goes on, they bolt the roof and everything, don't they? And they make it all safe. Much less so in the big driveways where you're going. I think that's it, actually. I think I've run out of pictures now. But that's the mine. But it's a dead interesting place to go, to be honest. I'd go there tomorrow. You know, did I wrote down things? 9 meters. Yeah, I never saw I had a picture of the transit. What happened to that? Let's just go back through them all, because I don't remember seeing the one of the transits.
Do we?
Yeah. That's funny. I definitely had a picture of it. I gave it a funny name or something and lost it. I was going to show you the picture of the vehicles that they use, like. I must have lost it. How do I get back to the file, I wonder? See all photos, what's that? No. What if I close that? Oh, shit, now I've done something. I've stopped screen sharing now, haven't I? I've buggered it up now, haven't I? I've lost the bloody...
You can share it again, though, when you find it, though.
Yeah, I was looking for the file that the photos were in. I don't know. Let's just see if I can find the file again. It will be mine.
Would it be in one of your folders, the pictures folder or somewhere like that? It would be...
Yeah, well, I've got the folder there, so I'm not quite sure how to get it. No, okay, lost it altogether now. It was only really I think the vehicles perhaps that was probably worth looking at. They're only ordinary transits, like, but they strip everything off them, you know. Pickups they were, mostly transit pickups. I've bloody lost it. No, can't find it. Wonder what happened to that.
Yeah, Doug, I don't know if this is anything like, I've just done a search. Hang on.
Yeah.
Give me a sec. What we're on screen too.
I've just found where you stole all your pictures from, mate.
Have you?
And there's a transit there.
Well, that'll be the one that I.
Strangely
Yeah,
enough.
there it is. I can see it there. Yeah,
That one.
yeah, yeah. That's the transit that, or the like the one that we travelled around in. The
Strangely enough, I found the same one.
yeah. Hmm.
Bigger picture.
You make it bigger, like, so you can see it. It's a shame they won't let you take pictures, but I wonder whether they, how strict they would be with it. You know.
Why won't they let you?
I don't know. They didn't really say. They just said no photographs. And really, I was a bit scared of getting thrown out. You know, I thought I don't want to risk being banned or something before I've even seen the place.
I imagine that the photographs probably have a commercial value to them, and they don't want you to undermine that.
Maybe.
Or they might not want you showing the world some infringements of health and safety or something.
Possibly. Yeah.
When I was out in Kutna, which is in the Czech Republic, I went to a silver mine where you weren't allowed to take photos because it was dangerous, but you could pay €8 for a pass to take photos.
All right.
Yeah.
Was that a dangerous pass, was it?
It was, yeah.
You know, you mentioned that the metal doesn't tend to rust under there. What about the transits? Because they've got a habit of rusting.
What was that? Sorry.
You mentioned the metalwork down in the mine.
Yeah.
Tend to rust as such.
Yeah.
What was the transit like?
Oh, it was perfect, and I was, it interested me as well because I had a transit at the time and mine was rotten. I bought a transit brand new. I had it for 10 years, and basically, you know, mechanically it was brilliant, but the body just fell away from around it. You know, it just disintegrated. And these transits they had down there, they were like new. There was, you know, apart from scratches and that on them, but there was no rust. You know, when you scratch, if you scratch your vehicle, you know, to get a bit of a scratch on the door, within 2 or 3 days, you'll have rust on it, won't you? No rust on them at all, because the atmosphere is that dry. The salt just draws all the sort of moisture out of the atmosphere. And like someone said before, I dare say if you brought it out and brought it to the surface, it would only last a fortnight. But you know, they just it's amazing. In the steel down there, you know, the steel girders and things that aren't even painted and they're not even rusty. You know, it's amazing how much the sort of atmosphere just takes away all the moisture. It's weird.
That'd be like on Indiana Jones where they got the Fountain of Youth, and when he left the area, he aged to be 1 million in seconds.
Yeah.
Take the transit back out, and it'll be rust as soon as you get it outside.
Yeah.
That's exactly what happened.
Rust.
That's exactly it. Because the brother-in-law said to me a while back, there were generators and stuff they had down in the salt mine at Winsford. And he said, "Oh, we're bringing them all up soon," and they flog them off for like no money at all.
Yeah.
He said, and I said, "Oh, I might get one." He said, "Do you know what? I wouldn't bother," because he said, whatever you do, people try pressure washing them, taking them apart, washing them, drying them, covering them in WD-40. You can try anything you want, but they just rot bad as soon as you bring them up. It's almost like the salt gets into the sort of structure of the steel somehow.
I suppose it gets in the pores of the steel, doesn't it?
Yeah.
It's molecular structure, isn't it? Yeah, that's what it is.
He says like within you know, literally within hours of it coming to the top of the shaft, stuff that's been underground unpainted for years without any rust on it just rusts like crazy in no time. Can you still see that on my screen there, that directional drill? So there's lots of different types, but one of the oldest and most common methods is the end section of the drill. Is that what? That's probably what they use there.
Yeah.
But the end section, see the way it's got a bend in it, right?
Yeah.
So normally, as well as the drill going round, which can be driven by the fluid. So obviously they'll be pumping a drill fluid through here, a mud or whatever they use as a sort of lubricant and cutting fluid, right? That gets pumped through, and sometimes that drives. There's a hydraulic motor that actually can use the fluid to drive the cutters. But the overall drill string, the sort of blue bit, ordinarily is turning, right? But what you can do is you can stop it from turning, and because it's got a bend in the end of it, if you stop it turning in a certain orientation, the drill will tend to drill at an angle then. and then I don't know if I'll see if I don't know if you can hear the audio, can you?
I can hear it, yeah.
Oh, can you?
Yeah, I can't see it. I'm having problems with me screen. I can't see bugger all, but I can see a little tiny picture of this.
Oh, right.
Looks like a drill rod.
What's anyone else see? Can anyone else see it full screen?
I can see the full screen.
See it, but
No, I can't see the full screen at all. I'm messing about trying to get it back, but I seem to have left the meeting except the.
Well, come out to the meeting, Doug, and go and invite yourself back in, because that's what I did about half an hour ago.
Oh, aye.
Log yourself off and log yourself back in again.
Right. Well, I can't even find out how to bloody log myself off.
I'll tell you what I'll do, Doug. I'll send you this link. I'll just send you this link, and then you can watch it at your leisure then.
Okay.
But basically, the end section of the drill, there's lots of different types of directional drills, but this is one of the simplest and most common.
Yeah.
And the end section has got a 5-degree kink in it on purpose.
Yeah.
And if you want to go in a straight line, you turn the whole blue bit is going round as well as the cutter, and it just goes in a straight line. But if you want to go at an angle, you stop the blue bit turning, and it drills. It tends off then, whatever direction you stopped it tends off in that direction.